All right, object-oriented. So PHP allows you to do both object and procedural programming, and the object-oriented part is a little confusing, and it can be a little bit tricky because the way the language is, because it's a loosely typed language, just like JavaScript. So when you write functions or constructors and all these methods, you run into the issue where you might try to have, I guess, the option of method overloading, overriding. You remember those terms back in Java 1? Okay. I mean, you can have the same function name, except you have different parameters, right? And usually that works perfectly fine for the strongly typed languages like Java and C# and so on, because each parameter is different data type, so that's completely fine. But in PHP and JavaScript, like these kind of languages, they don't work very nicely. So you run into those issues. But let's look at these things here again. Review. Objects are the instances of a class, right? So you cannot have objects without a class, just like you cannot have a blueprint to build a car. Well, you don't need a blueprint, I guess, but a car is made out of some type of plan. So classes are the blueprints, if that's a better term, to build objects. And then methods, and also like attributes. These are the properties of the objects. Okay. So all these here are all objects. All you see on this diagram here. Everything's object here. Just going to show you what they are. It's a thing. A example I pulled from Java. Right. You have a class name. You have the class. You have the data fields and methods. So basically, these are the two things that you usually have that will describe an object of the class. So we call these data fields, or these are basically just variables inside the class, and then any functions in there are called methods. It's just a better term they use to apply to most object-oriented languages. So you use methods instead of functions and procedures. It's called methods. And classes are, again, a collection of properties and methods. Right? They are bound to the objects. You can have pretty much unlimited number of objects out of the same class, right? Just like we are. We are all objects of the human class, for example. And they all share the same properties if they're of the same class. Okay, so here you see an example in PHP how you can create a class. The word keyword class followed by the name of the class. The same convention as in Java. You always capitalize the names of your classes. Okay, although the only rule is not the same as Java, is that the class name doesn't have to be the same as your file name. Okay, in Java, you have to have the same file name as your class. But PHP, it doesn't really matter. You don't really care. Okay. So we have the data members, what we call fields or data fields. These are right here. And they can either be private, public, or protected. And then just the actual variable name, and then you can have methods in here as well. So these are called fields or data members or data fields. That's what they are referred to. And then the methods are called properties, or what we call it's both of them. We'll see properties really applies to both of them. Attributes. So here we have an example again. Well, this is just data.
So those are properties of the student class?
Yeah. If these were inside that class, in this example I didn't show it, but if they were, yeah. So I didn't put the ID in here, but the ID wasn't here, then those would be like the properties. Or the attributes, yeah. So the word property and the word attributes are really like kind of vague. It applies to both the data field and the functions as well. If you want to be more specific, you would say the actual data fields. That refers to the variables. And then we have the methods will be the actual functions and so. But they're all properties. Oh yeah, in other words, like instance variables. If you have this term, these all applies to apply to objects or a class versus a local variable. It's different, okay? Because a local variable is only those that are declared inside a function. We call those local variables. When you have the word, you see the word instance, automatically in your head you should think of that these are part of the class and not inside a function. Okay, it's instance, I mean it's always applied to a class. So they're all global in this case if you think about the scope. And all these mean the same thing. Data fields, data members, instance variables, they all mean these right here, these variables here. Okay. So the access modifiers, we have three here. You have the public, private, protected. There, I think these are only three available in PHP. Other languages have more, like Java has a lot of them. Java has like the friend. There's an, I think probably there's another one too, but usually these are the ones that you can use. The protected is, the public we know, right? Public means available, can be accessed by other classes outside of the main class here. Private can only be accessed within the class. And the protected is only be accessed by another class that is a child class of that class. So it's like the parent and child relationship. So if it's like say a cat is a subclass of animals, then only cat can access the animal's data. Okay, if dog is not a subclass of animals, then dog cannot access those data. If the fields in the animal class are protected. Okay, so it's that relationship. So here I have the public is any class can access it. We have the protected, the class and derived classes only. Derived here is the subclass or the child class. And then the parent class is called the parent class or super class or base class. Okay, we'll learn again those next week. And then we have the private class. The private here is only for that within that class. Okay, so those three different modifiers or accessors. So methods here, the actual functions of the class or the object. Think of method as function. It should do something, right? It moves, it calculates, it outputs data, reads input, gets data. All those are methods. And these are also called mutators and accessors. So, or setters, right? You have different terms. So, and notice that the term here is the methods are the verbs, right? Methods are the verbs, whereas the data fields are the adjectives. Okay, so these like action verbs. So you have the actual functions of an object. The mutator methods, these are also called the setters. You hear the terms setters and getters. Okay, so it sets data. So these are actually the settings only. So when you set data, usually you don't return a value. You just set it and you're done. Okay, so there's no return values. And then we have the accessors, or these are called the getters. You're retrieving data, so therefore you should return something. Right, so you return a value of some sort. And then we have the non-static methods. Again, these are, you have the non-static and you have static methods also. The difference between the non-static and static is is depending on how you access that data or that function. So for a non-static method, is you can call that function directly. If you were to, let's see if we can show some example later on. The non-static functions, you can access that function by going to the class name, and then from that class name you put, I think, like 2 colons, and then you call the function name. Okay, you don't have to instantiate an object. But if it's a non-static method, then you can only access it through an object. Okay, we'll show what that means later. You'll see what that means. So it's, again, the word is instance here. Okay, and every class should have a constructor. So constructor is just a special function that constructs that object. Okay, so you cannot create object either without a constructor. So every language that is object-oriented always have a constructor. It's just like the initial function to build that object, whatever that object is. Okay, so, and as you can see, this is very different from Java. In Java, the constructor is always the same name as the class, right? So if you call a class called dog, then the constructor always has the name dog, right? It's new dog with the name, whatever it is. But in PHP is the word construct with the 2 underscore in front. Okay, this is always a constructor. And if you remember in Java, you could have a lot of constructors, right? One could be empty, one has a one variable, one has 3 variables, one have all the variables in there. You have multiple variables, constructors. In PHP, you can't do that because whatever I put in here, I might have 1 variable, I have 10 variables, doesn't matter. It will truncate all the extra things that pass to this constructor. If I don't have enough variable to receive parameters to receive those data, it will just ignore the rest. And if I expect an integer but I pass in a string, it will accept that too, right? So there's no way of having multiple constructors. So really, you'll really see you have multiple constructors in the class in PHP and also in JavaScript. Okay, so here's just one constructor and also one destructor to destroy the data. So just remember this name, the underscore construct, and that's your constructor. And Visual Basic is actually the word new. It's a function called new. So again, they have their own language syntax, but the concept is the same. This is used to construct the object for that class. And it cannot have a return statement, right? You cannot put return. If you put return statement in there, it will throw an error. So that's a constructor. So here we have a constructor here. They have a student class, have 3 fields that we saw earlier, and then the constructor here is to construct the student. Okay, so in this case, this is a empty constructor, has no code in here in this example. You could put in there. So usually you have like the code to initialize all these fields, because right now they're all empty. So when you construct a new student object, you would fill this with some data, right? You will populate those, what we call those initialization, and then from that point on, then that object will be existed and has some data. Okay, so that's how you create class, and then how you instantiate an object is very similar to Java. It's the object name, whatever that object is, and then equals to new, and then that class followed by the paren. And the paren here, you can pass arguments or data to it depending on the constructor type. Okay, so if you don't have anything in the constructor, then really there's nothing there to pass to.
So would that be considered like a subclass or a child class or a derived class of the student class?
You mean like
The student one.
No. Student one is the actual object, right? So this is like the blueprint. This is the actual object of that blueprint. Okay, I could have another student 2 down here equals to new student also. Okay. So right. So in order to use this student class, all this data here, you have to instantiate a new student object. Okay. So this is the term instantiation is the new keyword. I can't just suddenly use student 1. I have to create it. So when you use the new, it will create a new object. And then once that's been created, then the student one can now have access to all these properties in here. The fields plus the functions or the methods in here, which is not shown here. Once it's been created, it can. Yeah. Okay, so that is the instantiation. We'll do some example, a lateral. And then this reference or this keyword here is really important, and especially in PHP. You use this sometimes in Java to access the parent or the global variable or instance or the field. In PHP, it's required. Okay, I'll show what that means also later on. But here's an example of that. So for example, I have the class student. Okay, it starts here, ends down here. I have a field called age. It's public, so it doesn't matter in this case. I call field. And then I have a function. In this case, it's a method that show the age information. And all I'm doing is I'm going to print this age out. Okay? So if you look at this way, if you think of the way how you write functions and stuff, it should work because this is a global variable. It's outside of the function. And I can just print age and it will grab that and display it. Okay? You will assume that it works, but in PHP it doesn't work. Okay? If it's in a class, it won't work because there's no way of getting to this variable unless you put the word this in front here. Okay, so it's, you have to use the keyword this to reference any data fields in the class space here.
So is it this dot age or is it?
Yeah, so there'll be like the $sign this.
Oh.
Yeah, so PHP uses that arrow.
And that's not lambda. That's
No, yeah, right. Good question. Yeah, no, not lambda. This will be just.
really?
Yeah, this is the same as this in Java, right? So in Java you would use this .age, but in PHP you have this with an equal sign .age. Because if I do this in PHP, what does that mean? Yeah, so that's the dot is used as a concatenator in PHP, so that's why they stuck with that. So they have to come up with a different symbol to reference it. They use the arrow. Okay, so let's go back here again. If you were to, and notice also I don't put the $sign here again because I already put outside. So that means you cannot put it again and again here. So that's something that you want to. I'll see down here in the next one here. It will look like that. Okay, so you have to reference the word this, and then the arrow, and then the variable name without the $sign. So you can't have two $signs in here. And I can't do this either. Okay? So it has to be exactly as that. And this holds true for if I call a function as well. If I have a, for example, if I have a function down here, you know, x, it does something. So if I want to call that function, and if the function returns some data, I will say something like this as well. I have to say print the result of this function called x. Okay, so you can do it this way as well. Let's assume that x returns a number 45, for example. Then that's how you call that function. Okay, because it's outside of the class here.
Now this is going to sound silly, but will it see that because it reads straight down and function x hasn't turned?
Yeah, that's fine.
It will read that?
Yes, because
Because of the call?
yeah,
It looks for the function?
yeah, this is function call, but this one function. I'm calling this function inside another function. Okay. Yeah. So
But I thought the same thing. Seriously, I thought,
Yeah.
well, it didn't get that far, so how is it going to read that?
yeah, and these are all these are in the class, right? So in the class, the function order doesn't matter in the class. You can put up, below, doesn't matter. It doesn't really care.
But function x is within the class.
Yes, it's within a class. Yes, it's still within the class.
It's not within that show info function, but it's
Right.
within the class
Mm-hmm.
itself.
Yeah, it's in the class. Okay, so just remember that when you insert a class, if you want to reference anything outside of your function, local function, in the global space out here, you must use the keyword this. Okay, to access. If you ignore it, it will throw an error and you'll catch it.
And just like in your second print statement,
Mm-hmm.
because that's not really part of it's a field in the class, but it's an object of the class, right? That you still need this keyword.
Yeah, because this function, it's a function, but it's in a global space. Because in PHP, I could do this. I could put this function inside here. If I do that, then I don't need to reference this because it's already local to that function. Yeah. So anything outside of it, you have to reference with this. And so, if you remember Java, this one here, if I have this, I will grab the global space here. If I have a variable passed to it called age, then if I access this variable, I just do that without this, it will grab the local variable, right? Because that's Java. I mean, that's how it is. But in PHP, if I just do this, then this age is really just this age. Makes sense. To grab this age, I have to put that this in here to get that age out here and not the local age, right? So the same holds for Java. So just remember to use the this here. And we'll do some examples. Mm-hmm.
Put age back in as the argument in the show info. Now, you got your print statement that says this age.
Mm-hmm.
That's going to print the public field.
Mm-hmm.
But what if you wanted to print
This?
What would you just write print age?
Yeah. Just like that.
You could possibly get two different values.
Oh yeah. This one here will refer to the value passed to it. This one here refers to the global variable up here. Okay. It's good question on the test. So yeah, so that's a really good question. Are we good here? Okay. And then data field encapsulation. Again, this is another big word for object-oriented. Encapsulation means you hide your data. And then this just means either private or public. Okay? Encapsulate means you hide your data so that other objects cannot access it. They cannot know what those data are. It's like a black box. So you produce that black box concept. So this again, back to the student class, we have 3 fields. It's all private. The only way to get this data is from another function here, or functions down here. And this function must be set to public. Okay. So because this function is public, I can get the data of the name through a function called getName because it's public, and that function is part of that student class, so therefore it will return the name back. So in the outside, another object outside of it can get the data only through its public methods. Okay? So in other words, I cannot directly go into the name and get that here.
So in this example, what would that return?
This?
Yeah. Right now the field it's not
yeah, well, yeah, it won't until let's say if I go down here, if I say S1 is equal to new student, right? If I do that, as soon as that statement runs, it's going to go into the class called student, look for a constructor, and then this constructor here has some default values for data. Here I did not supply them, but that's fine, right? I didn't supply any data, but it's going to take this data anyway, and then assign that to initialize the name here to this name, this ID to this ID, and then this GPA to this GPA. So here again, I did not specify that this here because it's local. This is the global one. So when this constructor runs, it will create that object called S1, and the S1 will have the name of John, ID this, and GPA 0. So now when I want to get the name back, I'll call down here, show me the name of John. So I'll say print. If I do like a print statement, I'll say print S1. Okay, use that. Get name. And that will call a function called get name. And then it will call this function, and this function will return the value of this name, which is this name with a global space. And then whatever that name was is John, so it will return John to this when it prints it out. Okay, so I call it function. I cannot do this. I cannot call the name directly because the name field is private. It's set to private. Okay? So if this is a private, if all these are private, then none of this will work. I can't access them. Okay. So that's how you use the get name to get that name back. So all it does is basically just return the value of the name, return the value.
That name is what's setting it to John, basically, right?
No, you set it by default because these are default values. Okay, if you don't supply any values, then this will be set. I set it right here. When the constructor creates this object, it will set the name automatically.
But it's initializing the global variables, correct?
Mm-hmm.
To those three
Values, data.
So after the constructor,
Mm-hmm.
now those global variables are the name is equal to John.
Mm-hmm. Yes.
So the set name function, when would you use that then?
If I want to change John to James.
Okay.
Yeah.
You want to change it?
Yeah.
Okay.
Yeah. So they only exist in here only when you want to call a function. If you don't call them, they don't do anything for you. Yeah. So if you want to change the name to a different name, here I didn't supply the setters getter for ID and GPA. You can also do those as well, right? If you want to change the GPA because of I got a better grade, my GPA should be changed from 0 to 3. Right? So you need a setter as well, so they look the same, the setter and getter. Again, notice that the setter, the getter, I'm getting the data. I'm not passing any parameters. All I'm doing is just returning the data back. Okay, so you have the return statement. It's set, I'm just setting data. Well, when I set something, I need to pass something to it so it can set it to a new value. Otherwise, how does it know what to set to what, right? So you pass the parameter, and then I'm just changing the value to that new value, and I'm not returning anything. Okay.
So if you wanted to change the name to Jerry in this statement before the print get name function, would you do a set name?
Yeah.
Set name function and put in Jerry?
Yes. So I'm going to go down here. I have more space down here. Right, so you will put S1 set name, and you pass in the new name called Jerry. Right?
And then with the print function,
And then now it's going to print.
get name function, that's going to print Jerry.
Yes. Because now it's been replaced with Jerry.
Okay.
Okay. Coming back now? All these things.
No,
No? Yeah, only I think only PHP.
From their first PHP class.
No, you didn't get to use that because it's not object. You didn't get to know object oriented. Yeah, yeah. So it's all procedures in the first class. Yeah. So here again, kind of same thing. I can get the name. I mean, I can echo the name, echo the ID, and echo the GPA. I'm just saying it doesn't work because these are all private. Okay. If it's public, then I can do this directly. I don't need to call the function, and I can set the name directly from here as well, right? If it's public, so I can just do this. I should say student1 name is equal to Doug, and that will be set. It will set that name. But since they're private, you have to call the function to set it. This function here. Okay. So when you want to print their name, the ID out this way, because they are private, you cannot access those fields directly. You will call the function name get name, get ID, get GPA, and you print those out. And when you set name to Doug, or just do it to Jerry, you do the set name to get that name set to Doug. All right.
That would print Doug in the echo statement because it's being read afterward.
If you did an echo statement right under it, then it would say Doug.
Mm-hmm. Yeah. Okay. Yeah, we'll do some examples after this. This is the last piece right here, called serializing objects. Okay. When you create objects like this one here, when I do the instantiation of a new student called as student1, and I got the name, John, and 1, 2, 3, 4, 5, and GPA 0, all those data are only stored in RAM, right? Only in memory. When you shut down the page or you close the program, everything gets wiped out. Okay, so because they're in the object only. Now, serialization is a special feature that allows you to actually retrieve the data from that object, all its data, and then save it into a text file, okay, or into a database, a table, and then you can read those data back and then put it back into the object in memory. Okay, so you don't lose it. If that's something that it's important, right? So this function called serialize is to convert the data of an object to an actual string of data. This is like a physical hard data. You can actually use those data and save it to a file. You can retrieve them back and use them, or you can actually see it in a file, except the file isn't binary, so you can't really see everything. You can't read it. Well, I guess you can too, but it has some different data included there as well. But at least you can save the data to a file, so that even though you close your program, those data still exist. And then let's say at a later time you come back and you want to reuse the same object for those same data, same state, you can just unserialize it back, and then you will repopulate the whole object with all those data into its previous state. Okay, so you use this to serialize data. And so for example, if I have, and this is just the function here, okay, and let's say I have here a checking account class. I have the account number, the customer name, and the type and the amount of money they have at that time. So I instantiate an object called checking, has those numbers, and then before I close the program, I serialize it, serialize this checking data, and save it to a data called save count. And then I didn't have this step here, but you can then output the data to the text file or to data file. You make a hard copy of that. And then if you close the program, you can come back and unserialize it back to another object or the same object, and you get the actual data back again to work from where it was left off. Okay, this is good for only, let's just say, if you don't want to save things to a database. So usually you do a database connection, you set the data to a database, and you close the program, everything is safe, right? So, for example, if I say I want to serialize the word apple, then if I print that out to the screen, you'll see that it has this is like the anatomy of these different types of data. If it's a string, the value is a string, it will tell you S as a string type. And this is actually what you actually see inside the file, or the actual data. It will be stored in this way in the binary file. The S is for string, and then followed by the size of that string, how many characters you have, and then the actual value of that string. Okay? And you will see this, and then when we undo it, it goes back and put all things together again. If it's a number, the integer type, then it will put the integer plus just the value itself. And then if it's a decimal number, it's kind of the same thing. The D for decimal, and then the actual value. If it's a Boolean, true or false, then you get a 0 or 1, not the word false or true, of course, right? So you get 0 or 1. And it's B for Boolean or binary. I think it's Boolean. And then if it's null, then there's nothing. Which is N, there's nothing. So if I were to say cat is null, I serialize that, then the value just basically is null type, but there's nothing there. Okay. And then for this array, it will look like this. Actually, I have it incorrect here. I shouldn't have that. Oh yeah, that's right. So array of 2 elements, right? 1, 2, 3 apple. So array of 2 elements. The first element, 1, 2, 3. Yeah, I of 0. The index of 0. Index is integer type, right? So 0 is integer. The data is a string. It's 3 characters long, and the actual value is 1, 2, 3 is a string. The second index is index of 1, which is an integer. The reason why it's integer here because you can have the associated array, right? And then they have it's also a string of 5 characters in the words apple.
So I is the index value.
Yeah, I is for integer and then the index. And you could, yeah.
Integer?
Yes, I for integer, because usually it will look like this. The 0 index, the 1 index, right? When you reference an array, you reference like this, right?
Yeah.
Yeah, so you reference like, if it's like array of 0 is apple. This is 1, 2, 3. The index of 0, this is an integer number. That's why it says integer. The index is integer. If I do this way, num, if I do that, then this will say string has 3 characters, and is the actual value is num as the index. This is just the first index. It's a string, has 3 characters, and the actual index is called num, and it holds the value of 1, 2, and 3, right? So that's how it would do this automatically for you inside the binary file. Okay, that's how it's stored and converts in there. I'm not sure if you remember the associated array. This is the standard array with the 0 number as the index. You could have other values in here. This don't have to be a 1. It could be like a fruit, right? Fruit will map to the word apple. And in this case, it's a string. Okay, so here's a better example maybe. Object, right? So I have the pet class called my pet. Has a name Otis. It's a private. And I can get this Otis name by using the get function. So this name returns the name Otis. I create a pet object that note my pet. So now pet has the name of Otis. Now if I were to serialize pet, okay, then so basically I'm just serializing its name. That's all I have in there. So when I do that, then the name is get into a string. It will look in the same object, the same method here. It will be a string type and has that many characters. I think I have this somewhere. It has 4 characters and the text is Otis. So when I output that, I'll get this. It's an object. Okay. Have 5 characters. It's called object called my pet, the class name. Has 1 object. And then my pet name, and S4 and so on. So I want to show is that when you serialize this, you get this data put into a string, and I'll store this data into the value of P1. Because P1, well, we actually call it pet. Let's call it pet. Oh no, I'm sorry. P1 or pet. I serialize pet, the object here, into a P1. So P1 now has a string here, this information here. And then P2, another pet called P2. I unserialize the data from P1 to P2. So now P2 has the same copy, same data as P1. And if I were to print its name out, I'll also get Otis. Okay, so this will show that here I did not instantiate P2 at all. I did not set any size, any data for P2, but because I unserialized the P1 to P2, all these data, how many ever there are, is going to be passed into the P2, and P2 has the exact same copy as P1, but now it has its own. It belongs to itself. So again, if you same thing as saying I'm reading a data from a text file to another object and the code and accesses data without instantiating P2 at all, right? Usually you would say P2 is equal to new pet, and then I get the name and so on before you can use it. But now, since you have serialized it, PHP knows that it will put Otis to this class and to the name here. If you have other data, it will be pre-populated, and then this P2 will have all those data with it, and then it becomes a regular object in that program. Okay. So I mean, don't worry too much about this. I'm just showing you how that's done, and how other programs also have something similar, like in Java has it too, and most languages have them. But this is what it means by you serialize and unserialized data, is to actually break down the data in RAM, because right now everything's in RAM only. All these here, only in RAM. When you close it, everything's gone, wiped out. So how do you save it to a physical file so you can access the data back again? Is by serialization, okay, and unserialization and so on. Okay, any questions before we take our break? Okay, let's take a